Hello, honors algebra students. Mrs. Messier is here, and hopefully, if you are watching this video, that means you might need a little bit of help with your chapter review problems. And so I am going to work them all out for you on the board. And so if you need to pause to think about something, to listen to an explanation again, or if you need to fast forward through because you didn't miss some till the end, then you'll be able to do that. All right, here we go. Okay, number 2, we have 4 to the third raised to the second power. When you raise a power to a power, you multiply your exponents. So we're going to have 4 to the 6, which means 4 times 4 times 4 times 4 times 4 times 4. Really big number. If that number comes out to be over 100, I'm okay with you leaving it like this. If this was a small number like 2 to the 6, that's less than 100, so you can go ahead and leave it like that. Okay, the next one, we want to combine and so only end up with one W term, one X term, and one Y term. So the first thing I'm going to do is get rid of the parentheses. So I'm going to distribute that squared sign to all 3 terms inside the parentheses. So that's going to become W to the, we multiply those, so W to the 6th, X to the, again, we multiply them, so it's going to be X to the 8th, and then Y, there's really an understood 1 here if there's nothing there, so that'll become Y to the 2nd. And the same thing over here, distribute the 4th power to each term. So that's going to be W to the 4th, X to the 8th, Y to the 12th. Now we have 2 sets of terms being multiplied, and the only ones we can combine are the ones that have the same bases. So W to the 6th times W to the 4th, that means I had 6 over here, 4 over here. We add those powers, so that means we had 10 W's in all, so I've got W to the 10th, X to the 8th, X to the 8th. Add the powers together, so that's X to the 16th, Y to the 2nd, Y to the 12th, add the powers together, Y to the 14th. Next one, on number 6, I have S to the 4th, and I have negative T to the 3rd. The one we really want to focus on is the negative T to the 3rd. That means I'm multiplying negative T times negative T times negative T 3 times. So I know I have 3 T's, so I know I'm going to have a T to the 3rd. And I know I have an S to the 4th. And the question is my answer positive or negative? Now, if you think about it, every time you have 2 negatives, they cancel one another off. So those 2 negatives make a positive, and I end up with 1 negative sign left over. So my answer on that one is a negative. Now, this one's a little bit different because the negative sign is in front of the parentheses. So in that case, think about that like a -1 being multiplied by this term. So we do exponents before multiplying, right? So I'm going to go S to the 2nd power, T to the, multiply them 4th, and then this -1 is still being multiplied and hanging out in the front. So you could either write it as -1 or just negative S to the 2nd, T to the 4th. All right, sorry if it's going to wiggle for a second. I'm just going to move this over here. I pre-wrote the problems to save us a little time. Okay, number 10, same base being multiplied. Now, what I want you to think about is sometimes people are tempted to write this as 49. The base doesn't change because this means I had 6 7s being multiplied together. This means I had, well, if it was just positive, it would be 4 7s being multiplied together. Okay, so we still have 7s being multiplied together, so don't change the base. Okay, so my base is still 7. Add the powers, -4 plus 6 is 2. So I've got 7 squared, 7 times 7 is 49. Next one, first one that we have with a 0 power. And the rule that I told you earlier in this section was anything to the 0 power is equal to a 1. And then anything over here, I have 1 over 4 to the -2nd. That 4 to the -2nd, we don't want to leave the power as a negative. We want it to turn into a positive power. And the way we do that is by moving anything with a negative power to the other side of the fraction. So that goes, it becomes 4 to the 2nd up on top. And so that 4 to the 2nd is 16, 16 times 1, so it is just a 16. Problem number 14. 1 is happy, 5 is happy. And when I say happy, I mean they have a positive power, so there's no need for them to move. Same thing with this P to the 8th. It's a positive power, so it's going to stay in the denominator. The only one that's going to move is this Q to the -3rd. That one moves to the other side of the fraction and becomes Q to the 3rd up on the top. Everything else stays the same. So there's still a 1 there, which I can write, or I don't really have to write. And then the 5 and the P to the 8th stay on the bottom. Number 16, we have 2 terms in the parentheses raised to a power. what I want to remember is whenever I have more than one term in parentheses and they're being multiplied, raised to a power, that means each one separately gets raised to that power. So my first step would be writing it as -2 to the -4th power and y to the -4th power. My second step is to get rid of the negative powers. We want to write them as positives. And so the way I do that is we could technically think about it as over 1. That's going to drop both of my terms into my denominator. So -2 to the -4th is going to become -2 to the 4th power down here. Y to the -4th becomes y to the 4th power down here. Everything got canceled off of the top, so it just stays a 1. Now in the bottom, -2 times -2 would be 4. And there's 2 of those, so times 3 and 4, so that's going to be a 16. And then we have y to the 4th. So I have 1 over 16y to the 4th. My next one, I have 5 to the 2nd over 5 to the -2nd. We could think about this one a couple of different ways. If you want to use the little rule where we subtract powers, 2 minus -2, the two negatives make a positive, and so that's going to be the 4th, so it's 5 to the 4th power. The other way you could have thought about that is 5 to the -2nd would have become 5 to the 2nd up on the top. And when we multiply it by that other one, we would have added the 2's. So we get 5 to the 4th power. All right. Next up, right there. Okay. I have 10 over number 24, 10 over 7 raised to the -1st. What I want you to think about is each part of that fraction gets raised to that power. So I've got 10 to the -1 over 7 to the -1. I need to make both powers positive. So that moves the 10 to the bottom and makes that a 10 to the positive first down there. And it moves the 7 up. And so it makes it 7 to the 1st power there. So I have 7 over 10. Number 26, x are my bases. My terms are being divided, which the quick way of doing this is subtracting the powers. So that becomes x to the 6th. What you want to think about here is that you had 12 x's on the top. I'm not going to write them all out. And you had 6 x's on the bottom. 6 of those cancel, so you end up with 6 left, and those 6 are up on the top. Okay, question number 28. Let's get rid of the parentheses first. And so raising a power to a power would give me p to the, we multiply those, so 6 on the top. Power to a power, we multiply those, so I have p to the 10th on the bottom. Let's do this one the other way. We could subtract the powers if we wanted to, or I could say p times p times p times p times p times p. I'm doing this one out the long way. And then this one would be 10 p's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what we can do now, since everything's being multiplied, I can start canceling off p's. So I'm canceling off 6 p's. There aren't any p's left on the top. There's 4 p's left on the bottom. So I have 1 over p to the 4th. Now some of these next ones start to get a bit ugly. Just a lot of parts. And so what I'm going to try to do is simplify them up a little bit and just make them less confusing by breaking them into parts. First thing I'm going to do on this one for number 30 is we can do a little reducing inside of the parentheses before I raise to the 3rd power. We could go ahead and raise to the 3rd power first, but then the terms I'm going to deal with are going to be bigger. Okay, so what I'm going to say first of all is 25 divided by -5 is -5. If I look at simplifying the a's, a to the 2nd, or sorry, a to the 4th over a to the 2nd, subtract the powers is a to the 2nd. B to the 5th over b to the, no power there, so 1st. So that would be b to the 4th. That's this simplified. Now I need to cube it all. And so I got to remember to cube each of those 3 terms. So I'm going to go -5 to the 3rd. So -5 times -5 times -5. So -125. A to the 2nd raised to the 3rd. So multiply those powers. So I get a to the 6th. And then b to the 4th raised to the 3rd, multiply those powers. I'm going to get b to the 12th. Same idea on the next one, on number 32, but we have 2 different fractions. The thing is, it doesn't really matter they're 2 fractions. If I want to think about it as one big fraction, I can. Now, first thing I'm going to do, so I can do some simplifying, I'm going to go ahead and multiply this out, my parentheses. So I'm going to rewrite this as 3 to the -2nd, x to the, multiply those together, so -4th, y to the -2nd. Okay, so let's just get rid of that for now. Now what I like to do is split this into parts so that we have smaller bite-sized pieces so it doesn't look quite so big and scary. So the first thing I'm going to do is what constants do I have? Meaning numbers, I'm not looking at exponents. The numbers I see are a 9 and a 3, and they're both on the top. And everything in this whole set of two fractions is being multiplied. All right, I wrote that, I wrote that. Now I'm going to gather the x's here. And what I like to do is I like to not deal with negative powers in the middle of this. So every time I have a negative power, I'm going to rewrite it as positive power. So right now I have x to the negative third on the top. I'm going to write that as x to the positive third on the bottom. The other thing I had on the top right now is I had x to the negative fourth. I'm going to write that as x to the fourth on the bottom. Down on the bottom currently I had another x to the fourth and I had an x. I'm just going to leave those there for a few minutes. We'll come back and simplify those in a second. I'm going to do the same thing with the y's now. I have a y to the 6 up on the top, leave that there. I have y to the negative second on the top. I'm going to write that as y to the second on the bottom. I have y to the negative fifth on the bottom, which becomes y to the positive fifth up on the top. And then I had y to the third on the bottom. Okay, so I've got this whole thing rewritten, broken into parts here. And I'm going to simplify each of those parts. So I see 9 times 3, so that's 27, and that's in the numerator, so that's my number part. All the x's I have are in the bottom, so that's fine. So let's count them up. We have 3 plus 4 is 7, plus 4 is 11, plus one more here, right, is 12. So I have x to the 12th. And then I can combine the y's however I want. What I kind of see happening right here, just as kind of, call it a shortcut or not, don't I have 5 y's on the bottom? We had y to the second and y to the third. And that's going to cancel off with, so that means I have 5 in the bottom. That's going to cancel off with a 5 right here. So why bother combining them and then taking them back out afterwards? So those two cancel off. I'm left with the y to the 6th up on the top. So my final answer should have one number and only one of each letter. And if you still have more than one of each letter, then what I would like you to do is do a little bit more simplifying. All right, excuse the wiggle. We're going to come over and we're going to do a little scientific notation. All right, if we have a negative exponent, that means the number was originally smaller than 1. So I'm going to move my decimal wherever it is, 3 places to the left on this one. 1, 2, 3. So my new answer is going to be 0.006667. Okay, 3.75 times 10 to the negative first. Again, if you have a negative power, that means my number was less than 1. So we move it over to the left one place. So I have 0.375. Now, if we want to change to scientific notation, we say, okay, I want to move my decimal point over until I have a single digit in front of my decimal point. So I moved it over there. Now, how many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8. So I have 5.23 right here times 10 to the, since this number was bigger than 1, it's a positive power, however many places you moved your decimal point. Opposite down here, we're moving over 1, 2, 3, 4, 5, 6, 7, 8, assuming that I counted the number of zeros right out of the book. And if I copied any of these problems wrong, I'm sorry, happens once in a while. Okay, so I've got 2.33 left. We always want to have one number digit in front of the decimal place. I moved my decimal over 8 places, but this time, since my original number was smaller than 1, that means my power is a negative. Okay, last but not least, I left myself some room over here on the board to go through the last couple of problems with exponential growth and decay. So we have y equals c times 1, it's at plus r to the t power if it's growth, or 1 minus r to the t power if it is decay. So 2 seconds, let me grab our textbook. Okay, so you were asked to do number 44. Okay, so the information was you started a walking program. The first week you walked 2 miles. So C is the starting amount. So that's how much you could walk right off the bat. Over the next 9 weeks, you increase your distance 5% per week. You're increasing, so it's going to be 1 plus the rate that you go up. and you want to find out how far you walked in the 10th week. And since everything was in terms of weeks, my time is in terms of weeks, and you just pop that into your calculator. Okay, this was number 44. I'm just going to set them up for you right now. Now for number 46, now let's see here, what do we have? Tennis club had a declining enrollment from 1993 to 2000. So we know it's declining enrollment, so it sounds like it's exponential decay, so that's going to be a minus. Okay. The enrollment in the first year was 125 people, so my starting value was 125. And it said the enrollment was decreasing by 3%, so go 0.03 since we're writing it as a decimal. Now, we want to estimate the enrollment in the year 2000. We don't put 2000 here, though, because we want to figure out how many years after we started was that. Since the first year was 1993, that in 1993, that was our t equals 0. So 94, 95, 96, 97, 98, 99, 2000. So 1, 2, 3, 4, 5, 6, 7. So we're looking at the 7th year. So that would a t-value of, so we're gonna write the 7 up there like that. Okay, hopefully you found this helpful. And please, if you still have questions, need any more explanation, I know I went through this kind of quickly, but if you do need any more assistance, give me a shout, shoot me an email, private message on Google Classroom, or a phone call to my house, 988-4730. Good luck on your test next week.